like it means nothing.
Everybody fresh and no headaches? Okay, good to see you here. Couple of words of who I am. I finished my PhD in 2003. Then I got out of the academic scheme and spent 15 years in a software development company in which I carried out consulting work, work in CISO office, CTO office, as enterprise architect, manager in software development and bidding projects, and look after the large biddings. And then I got back to the academic sphere as a hobby 2018 and started my studies in cybersecurity. And I was honored to receive Knight's Cross from my co-workers. Management of my company came to Jyväskylä and surprised me with this King's Cross, Knight's Cross, a couple of weeks ago. And I work as principal consultant in a company called Second Nature Security right away. And now I'm going to talk about my research, if the machine lets me do that. Got jammed. Okay, is this it? I'm going to see a literature review about things, topic of does DevOps development style decrease or increase the software security? And this research was carried out together with Tiina Leppänen and Andrei Kostin. Okay, DevOps has been here for a while, at least since 1997, and it has become the most used method for software development since. Someone had carried out a research on 2020 and thought that the adoption rate of DevOps is something between 50 and 90% in software development companies. So we wanted to study if it makes secure software more secure, having these practices or not. And we have two sub-questions we are going to tackle. One is, what are the most common postures and ways to secure the software, and what are the most common challenges for securing the software? Now it started to work. Yay! Okay, I have two sources of data for this presentation. One is, of course, this literature review I was referring to. It was published in BMSD conference in Switzerland 2022. And it was an update to a previous version, previous research carried out by Anna Koskinen. And in this research, we dig into these two questions: what are the most common challenges, what are the most common postures for software security. And then, because it's been 3 years, I sort of bring the results into this day, and I take the research carried out by Black Duck. It's an organization using a framework called as BSIMM to tackle and find out which kind of practices are there for software security and software development. And they have been carrying out research during 7 years and gathered data all over from 130 companies. So they have lots and lots of masses of data to compare with. So rest of the presentation is organized as follows. First, I'm going to talk about challenges, most common challenges for software security. Then we go to the ways of making software more secure, what are the common practices, and then we compare and bring the results up to date. And at the end there is summary if we have time. Okay, top 12 challenges for DevOps security are listed here on this slide. The most popular ones are on the top of the slide and the most least mentioned on the back row. And there are some brackets. These refer to the studies in which these challenges were identified from. Okay, and if you look at these challenges, don't worry, I'm not going to go each of them step by step, but if you look at these challenges, you can see that not all are related to DevOps development style. For example, ensuring pipeline security, is it closely intertwined with DevOps? No. Then if you look at getting developer security knowledge to the required level, is this closely intertwined with DevOps? No. So not all these lists are tied to DevOps style, they just happen to be there because everybody is doing the development by using DevOps style. But on the following slides I will look at these challenges in a bit more detail. Okay, I have grouped the challenges into groups with have some similarities with them. First, ensuring pipeline security, not very tied to or specific to DevOps. Then complexity of cloud or microservices environments. Again, not very closely tied to DevOps, but if you combine these two things and put them up with fast deliveries, balancing the speed, balancing the security, then you have a problem because you need to do quick things, fast deployments in an ever increasingly complex environment. And then when you are delivering faster, it means that you have to be fast on fixing your bugs also. So you are constantly delivering, deploying, fixing bugs, delivering, deploying, fixing bugs, and it goes on. And of course, when its speed is high, it's challenging. Then there is one challenge, including the security team in the development cycle. So this is something that perhaps we think that the security team is very busy. You have a fast schedule. You cannot find them. They are hiding in a coffee room or somewhere. You can't get them to do what you want at the minute you want them to do. So, of course, this is challenge, and it's challenge for the security team as well, because they cannot be just waiting for you to pop up with your, okay, I have something to test now. Okay, then there is a very interesting challenge. It may be something that increases our security, or it may be something that decreases our security. Increased insider access. DevOps development style means that there are people doing deployment, development and maintenance at the same time. In some organizations, it may mean that there is a mass of people going on. If you are not very specific on your security requirements, there are masses of people going back and forth in your environment. Some of them are testers, some of them are deployers, some of them are bug fixers, whatever. Of course, if you have strictly defined environments for development and maintenance and operations, it doesn't happen. But then one thing about DevOps, it praises the kind of style that people work together. For example, people do coding together. People peer review your code. It means that you may have twice a number of the coders than you used to have. Increased insider access. And then, of course, the more you have admin people coming to the environment, it always a threat to your security. But on the other hand, we have another culture in there. It is the culture of developers learning new skills. Developers want to learn new skills. They want to be testers, developers, deployers, maintainers, whatever. They want to wear many hats. And this means the number of people coming in could be decreased because one people wears many hats. But whatever the case, you cannot surely know. In one company, it may be one side and one direction, and on the other company, it may be the other direction. But it's an interesting question to tackle. Then there is this very obvious question about being in a hurry. When you are in a hurry, you want to automate everything. And you want to take out all the things that are manual and slow and require people coming in from the coffee room and do their tricks. And of course, balancing between these things is tricky because it may be quite complex to make large automated processes for everything. And then you have to tackle between these two things. Then this is most evident challenge for DevOps security, finding the right security activities and tools that fit your style and embrace your culture and let you do the things the way you want to do. Have pair coding, wear many hats, have a culture of sharing everything, be in a hurry. And of course, when you started this agile development, the tools were, there were no so many tools, and you didn't have any so sophisticated automation on those days. If you think it's something like 20 years ago when it started. And of course, it has evolved since then. But anyway, it's a challenge. How do you find the right tools and technologies that fit your life culture and style you want it to be, and be fast enough? Then, after reviewing these challenges, we are going to see what are the most common security postures and practices for DevOps software development style. Unfortunately, the security practices and postures does not come hand in hand with the challenges. If you are a researcher and you publish something, we have something like 14 challenges, please fix these 14 challenges, but it's not like that. People develop security postures by what is easy, what is evident, by what you have technologies for. But anyway, let's go and see what are the practices that are common. Before going to the practices, I have to bore you a bit with this diagram, which has lots and lots of small text you cannot properly read. I apologize. This is a picture of 4 domains for the BSIM framework by Black Duck. And on the left hand, you see there is a domain called governance. It means there are practices that help you to organize, set measure sticks, and measure how you are doing, train people for security, and other stuff. Then there is intelligence domain. This is the domain that has practices for knowledge, gathering knowledge about threats, doing threat modeling, doing practical things, and ensuring that you are on the right path and there are no flaws. Then if you move on the right side, there is SSDL touchpoints. And these are practices that are associated by or focused to a certain specific software or certain delivery or certain product. So they are deeply focused on the software product you have at hand. And on the right, there is deployment, and everybody knows what deployment is. It's the practice of how you publish everything you have been working so hard. How do you define that I am ready to publish? Are all the things checked out, roll out, and start operations and maintenance? And now there is a thing called a shift-left paradigm. And it means that if you are focusing on the security practices on the right hand, SSDL touchpoints and deployment, it means that you are focused on a narrow scale of software and its practicalities. And you need to shift left in order to build a base for your security and build up a whole base for being secure, thinking in a secure way, embrace the culture of being secure, putting security in every place, not just gluing on when you are deploying. And the more you go to the right, the more difficult it is to fix security flaws and bugs, and it's more time-consuming and more stupid, perhaps. So we need to shift left. But if we look at the practices that have been taken on, we are sort of trying to find out where we are in these domains now. Are we on the right hand? Do we need to shift left? Or do the practices scatter around the domains so that there is a good balance and harmony? Let's see. Okay, this is the most typical security practices from 2021 from our literature review. And again, you have some things in brackets there. The things in brackets in front of the security practice, it refers to this BSIM domain and a practice in there. And the things after the name of the practice refer to these literature studies, number of the studies in which these practices were identified from. So as you see, we read and analyzed over 40 articles for the study. Okay, and on top of the list there are the most mentioned practices, and on the back of the list there are the practices that got the least mentions. And again, I am not going to go through each of them in a thorough manner, but I'm going to pick up some of the most interesting ones. And again, you may see that if you look at these names, not all are related to securing DevOps environments or DevOps style of development. They are just common practices for everybody doing software development. Okay, the most interesting practices in there are ensure cloud security basics. Then another one with a little bit different flavor. Ensure host and network security basics are in place, and then perform a security feature review. These are the practices that are not so closely tied to DevOps development style, they seem to be quite universal. But it's noteworthy that if you look at the names of the practices, they all deal with security basics, not studying your security against some certain specific requirements. Then you have an interesting one also. You use orchestration. Okay, orchestration as per se is not interesting, but use it for containers and virtualized environments. Use application containers to support security goals. So this refers to the idea that we have containers, Docker, whatever. We have virtual machines. In the older days, we used virtual machines to hide old technologies and run old software in a new environments. And we just put it in a virtual machine or Docker or whatever, and we were able to run it in a new environment. So this may be a thing that increases or decreases your security. Many people think that if you have containers and cloud environments, it automatically increases your security. But if you think of it, it doesn't. Your environment or your software or your application, it's not any more secure if it's in container or not. It depends on the way how the container or the virtual machine is built. You can have a sort of a wormhole or lots of security bugs in your virtual machine. It doesn't make it more secure to have it in a machine or container. It may even make things worse if you think the fact that you encapsulate many kind of applications, software, technologies, you put it in your cloud. Then you have one cloud environment or two, whatever. Then you have lots of virtual machines, Dockers, containers, whatever, and you need to orchestrate them. And then as a maintainer, you find out that all these machines, containers and stuff have different kind of technologies, software, code you are not familiar with. So this even may increase the complexity many times and make it more and more difficult. And of course, it makes it more difficult to control the security. And then we come back to the dear topic of automation. So it's here, people want to automate, to be fast. Use automated tools with tailored rules. Use automated tools. Try tests with security requirements and security features. So this is something I was looking for. They are somehow considering the security requirements after all. But automation seems to be one of the keys that lets you concentrate on the more complex things in a manual way and use energy there. If you can, the more you can automate your things. Okay, so we have looked at the challenges. We have looked at the practices and postures. And now it's time to compare. First, I'm going to compare our academic findings with the findings from the Black Duck, which are more practical, so we can also perhaps see if the academic people have different kind of practices that the ordinary people or people doing the actual work. Let's see. There is a table showing the Black Duck top 10 from 2021. And at the time they had gathered data from 128 organizations. And it may come as a surprise, but not all the practices for securing software are the same with the practitioners and academics. But we found 4 matches, which on my understanding is quite good. So the first most common practice for securing your software in this Black Duck list is implement lifecycle instrumentation and use it to define governance. And it was the most popular among the practitioners, while on our review it was on the number 11th. But anyway, it was mentioned, not all the practices were brought up on the list of 14. Then we have exact match, which is sort of a miracle. Ensure host and network security basics are in place on both of the studies. Both in academic studies, it was brought up on the second place, and also on the Black Duck review. Then we have a next match, the perform security feature review. And the 4th match is use automated tools. And then, of course, we are curious what are the practices that academics didn't find at all, but practitioners were doing and thought it were most common. And these are identify P obligations. This is P stands for personal information. So the GDPR has come, and people have been impressed with the GDPR, and on year 2021, people are worried about being able to work according to GDPR regulation and product software according to that regulation. Then the practitioners had solved the problem security team hiding in the coffee room, and they had been clever, and they have used external penetration testers to find problem. So instead of waiting for the security crew to pop up, they hired external help. Then they also created or interfaced with incident response to be more quick to get the things rolling back if you encounter some kind of incidents or whatever problems. And they also wanted to integrate and deliver security features. Last of the list is ensure QA performs edge boundary value condition testing and translate compliance constraints to requirements. So if we look at this list, it seems to imply that if we are reading the academic papers, they are more done in closed environments and not perhaps containing the whole software development cycle and not considering the whole entity of the things that people in real life software development are tackling with. But anyway, it's a good match. And then these were the findings from 2021. So let's look up how are these practices, how have they evolved since? Okay, again I have to go here. And this is the same list and same table, but now we have again 3 same postures for security than we had on the previous slide, but they are not exactly the same. Implement security checkpoints and associated governance is the same, the name has changed. This BSIM framework is developed all the time also. So for example, on the time of 2021, cloud computing was missing from there, and use of AI was introduced in this framework this year, on this year's publication, not earlier. Okay, then we have ensure host and network security basics are in place. That's the exact match and the same as before, but now it's not so popular than before. Then we have this use automated code review tools. It's on the position 9, and perform security feature review. And if we compare this list, Black Duck list, with the Black Duck list 2 years before, we can see that there are 2 new security practices here that have arrived. These are unify regulatory pressures and create a security portal. I'm not quite sure how they're using the security portal, but my understanding refers that people are using sort of Azure Sentinel portals or dashboards or whatever, and they want to collaborate by using them. And then there is this mention about AI, artificial intelligence, coming into the scene on 2025. So this report here is not the newest one. I checked out the reports just before this happening, and they had just had the time to publish 2025 report on their web pages. And you can go to the Black Duck web pages and download all the data from there and find comparisons. For example, with regard to comparing between different industries and stuff like that, how are the security postures there? Okay. Now we come back to our framework. And if we put our findings of what are the developers doing, how are they securing their software, and we take the practices out and we put it into these BSIM domains, you can see that deployment domain covers 42% of the practices on 2021. It means almost half of all security postures are focused on deployment. Almost half. So this is not definitely shift left. It means that you are doing development in that old way and style when you are finding security flaws and bugs nearby the deployment or after the deployment, and you use masses of energy and time to fix them later on. Then SSDL touchpoints has 28%, and together it means that almost governance and intelligence are overlooked, heavily overlooked. And the shift right is very strong. Then we compare with findings from 2024. And you know, things have gotten better. Now if we look at it, deployment, it's 30%. 30% of postures are lying on the deployment domain. And what the heck, 30% of the postures are going to the intelligence, where you have things like penetration testing, gathering information about threats, gathering information about vulnerabilities, gathering information that helps you to define your security requirements and threats and ensure the quality of software at the early stages. Then the number of postures on the SSDL touchpoints, it has decreased a lot. So people are not so much focused on certain software or my specific software style, but they have started to have more broader focus on things. And also it's a very good thing to notice that governance has risen from 17% to 25%. So guess what? People have been doing a good work. And if we sum up these numbers, it seems that we can raise the bar and we can, in Finnish, laitetaan lippu salkoon, and congratulate ourselves because we have managed to balance between the security postures in a way that we actually, in true life, increase our efficiency, fix security flaws at the earliest phases of development, and have balanced postures of security on our organizations. Of course, this is only one black duck study, but anyway, it covers only 130 organizations, so I would say it is quite strong sort of implication that things have gone better. Then let's see, did we solve the challenges for the software security? And I have been doing something like lottery here, and I have been thinking and trying to figure out if these security postures can somehow be matched with the practices we identified and the trend we identified. And I found some good matches there. Balancing security and fast deliveries, it seems that it has been solved. We have found ways to automate things, and we have found ways to put the security practices evenly into these 4 domains. Getting the security requirements right, I'm not quite sure if I ticked that by having strong evidence, but anyway, it seems that we are paying more attention to the security requirements because we have had this shift left. Then balancing these manual and automated activities, I think the balance has been found or at least improved as we have gone on. Then the development process must be informed about the threat model of the service and functionality. It's sort of a horrible name for a challenge. But anyway, it seems that it has been solved at least partially because of this division of practices in the shift left. And then whether the security team is still hiding under a coffee room, it doesn't matter. It doesn't decrease our security because we have interfaced with incident response and we have brought in new people from external agents to ensure our software and test it. Okay, so let's sum up. We looked at these challenges for software security and found out that not many of them were per se related to DevOps development style. They were rooted on contemporary practices and contemporary challenges, fighting with Dockers and virtual machines in complex microservices cloud environments. Then we looked at the security postures and put them into the BSIM framework to see where is this shift, and if the security postures are scattered evenly on the domains and on the practices, and if we take the security into consideration as early as we could or as widely as we should. Then I think many of the challenges have been tackled, but of course there are new challenges. It's an evolving circle. We are never ready, we are never finished. We always find new challenges, new technologies, new whatever. There are some things that would embark attention from my understanding. And the first is this increased insider access. Thinking that these people who have more access and more people have access, and all of these people who have more access, they are privileged persons, they are administrators. For example, a customer of mine told me that in their software development environment, they have over 100 administrators doing the operations and maintenance on that environment. So you can imagine if you take 100 people, there are many kinds of people in the group of 100, especially if they come from different countries and cultures, using different tools, using different pipelines, using different technologies, whatever. Then getting the security requirements right and getting developers' security knowledge to the required level. Of course, we can always say that we need more training, but the thing that strikes me when we're doing this literature review, training wasn't mentioned in zero of the references. No one mentioned training. No one wanted training. And also, if you look at this BSIM, training is clearly lacking them. So if you have DevOps people that are developers, they want to become testers, they want to become threat modelers, they want to have many hats on their heads, why they don't need training? Okay, so is this it? Is this it, or is this that, or what is this? I cannot say for sure, of course, because I don't have a crystal ball on my hand. And I also didn't find any hard evidence on the way, one way or another, which is unfortunately the case when you are doing academic research. Most of the time you find some evidence that point out some direction, but you cannot never be sure. Your data may be somehow scattered, your data may be old, your data may be somehow tampered, whatever. But it seems that we have been improved. The shift left has been carried out. And then we have to go on and embrace the next challenges we are going to face, which is definitely artificial intelligence. Now, when artificial intelligence, they know natural language style and syntax, it's very easy for them to learn computer languages, formal languages that are more simple and have more simple grammar. And I suspect these low-code platforms are going to increase, in which you can sort of tell or say to the AI, I want this and that kind of software, and it goes and makes it. But it brings out challenges. For example, do we have a new shift right? Because it's easier to put automated things and AI and stuff on this right-hand domains again. I don't know, but we will see. And with these words, I would like to thank you very much for coming here. Thank you very much for listening. Have a great day here in Digital Bay. And if you want to chit-chat and share some ideas, I will be on the 2NS booth upstairs after the lunch. Thank you.